All right, everyone, welcome back to the AI Research Roundup. I'm your host, Alex, and today is May 4th, 2025. We've got an interesting survey paper today from ICLR titled A Survey of Interactive Generative Video, published just a few days ago on April 30th. This ICLR conference paper dives into what the authors call Interactive Generative Video, or IGV. Basically, tech that blends high-quality video generation with real-time user control and feedback. So the authors first show this really neat evolutionary tree. It lays out how IGV models have developed from 2020 right up to 2025. It's split into three main branches: neural game engines, embodied AI, and autonomous driving. Well, you can see the different types of models used, like GANs and diffusion, evolving over time within these key application areas. It really helps visualize the growing landscape they're surveying here. Okay. Building on that historical view, this next figure actually proposes a framework for these IGV systems. It shows how real-world inputs, like actions from players, instructions from designers, or visual data from vehicles, feed into the virtual system. Inside, it breaks down the ideal IGV into 5 key modules: generation, control, memory, dynamics, and intelligence. These all work together to create that interactive, responsive video experience they're aiming for. This table then drills down into specifics, focusing on generative video models used particularly in gaming. It compares a whole list of projects, looking at their underlying modeling techniques like GANs or diffusion, how they handle control signals and interaction type, and whether they operate in real time. It also assesses their creative generation and open domain control abilities, really mapping out the current capabilities and limitations across different approaches. Okay, so after looking at gaming, we see IGV making waves in embodied intelligence too. This next visual gives 3 concrete examples. How IGV can be used for embodied planning with models like VLP, how it helps create generalizable robot policies like UniPy, and its potential as a full-blown world simulator shown with Unisim. It really demonstrates IGV's role as a powerful environment synthesizer for training these agents. Following those examples, this table really dives deep into the models used specifically for embodied AI. It lists a bunch of projects, comparing them on tasks like manipulation or policy learning, the modeling techniques they use, often diffusion or hybrids, the control signals, and their outputs. Well, this gives a great snapshot of how different approaches stack up for training agents in these synthesized interactive environments, highlighting their applicability. All right, shifting gears from embodied AI, this figure spotlights IGV's impact in autonomous driving. It presents 2 examples. First, Vista, which uses IGV as a simulator for testing scenarios, taking in actions and predicting future video frames. Then, there's a driver eye at the bottom. This one uses IGV for interpretable vehicle control, linking images and actions via language models and diffusion. So it really shows IGV's dual role in simulation and control here. So, wrapping things up, we've seen IGV's journey from its roots through key applications in gaming, embodied AI, and autonomous driving. The core idea here is that these interactive video systems are a crucial emerging tech, and that 5-part framework, generation, control, memory, dynamics, intelligence, gives researchers a really solid structure for tackling future challenges. Okay, that's all for this week's AI Research Roundup. Thanks for joining me.